Good evening, everyone. Welcome to our presentation. We are from team PBL-TRPL401. Today, we want to present our project. The title is our project is IoT-Based Autonomous Ocean Trash Collector, or we call it PLECO. Before presentation, let us introduce ourselves. From me, my name is Juan Immanuel Tinambunan as front-end developer and backend developer. Wasin as system architect and hardware engineer. Ideal as UI UX designer and hardware engineer. Sela Rifki as front-end developer. Siva as business analyst and Aldreno Hosea as backend and microcontroller developer. Let's go to the presentation.
This is our problem statement and objection. The main problem is floating waste in coastal and shallow waters, which harms marine ecosystem and water quality. And our objective is to develop an autonomous robot that can detect and collect floating waste before it accumulates. Next. This is our product feature and benefit. Our robot is autonomous, provides real-time monitoring through a web dashboard, is lightweight and portable, and use rechargeable battery. These features make the system efficient, practical, and eco-friendly. Next slide.
Flowchart system. This flowchart shows how our robot system works. First, the robot captures an image using the camera. The image is then processed to identify whether the detected object matches the trend wash dataset. If no wash is detected, the system continues capturing image. If the wash is successfully identified, the robot moves toward the wash. When the ultrasonic sensor detects the wash, the robot gets open automatically to collect it. Once the ultrasonic sensor no longer detects any object, it gets closed automatically. The system then sends the wash information in JSON format to the server, where the data is received and stored in the database. After that, the robot continues monitoring for the next wash object. Next. Okay, these slides show the 3D design of our robot before the physical assembly process. The design was created to determine the robot shape, dimension, and the placement of its component according to the system requirement.
Right, in this slide, we have the agreement stream of our PLECO, our project. We have 13 components. First, we have the lithium-ion battery, which have 3.7 volt each, and we have two. That is attached to the battery holder. That is 3.7 times 2, it's equal to 7.4. The 7.4 volts will directly used by all the component, and before it will be step down with XL4015. It's a step down for the voltage, which the 7.4 will be 5 volt for all the current component. Next slide. In this slide, we have the image of how our robot work. The first is the robot will have all the component attached to it, and all of it will be gathering all the data. Some of the data will be directly sent by the ESP32 directly to the server via Wi-Fi and WebSocket secure, and then it will insert it into the database for the user to view it. And then some of the data will be used for calculating the robot movement by the ESP32 cam, which is for the robot finding another trash. Next.
Right, the next one is our robot implementation. Here is the robot. We are using catamaran design, and we are using PVC material to make sure the robot have good buoyancy on the water. The next one is the implementation. First, this is the API communication implementation using secure WebSocket. The robot connects with the API using a secure WebSocket and send the data such as the trash amount, the trash types, the location, or the battery remaining power.
Okay, this is our web dashboard. Here, user can see the wash data in real time. The system counts the trash like bottles and plastics. We also have an account list to manage users. Next. This is the account settings page. Users can change their profile details and password here. For safety, user must verify their email first to change the password. Next. We have our landing page and login page. The landing page show information about PLECO. The login page is where user log into the dashboard safety. Next.
In this slide, from this project, we learn three things. First, continuous testing is essential for integrating hardware, software, AI, and IoT. Second, we learn how AI and IoT work together to provide real-time monitoring through a web dashboard. And finally, we improve our teamwork, communication, problem solving, and adaptability by applying the agile approach. And this is our documentation for our progress to discussion. And this is our database implementation. We use MySQL to store and manage the system data, including user accounts, robot data, trash types, and monitoring records. And this database supports the overall operation of our system.
Okay, that's all from our team. Thank you very much for your attention and thank you.